Hello everyone and welcome in Computational Design in Arabic. In this video, I want to celebrate this great logic that we developed. So lately, we are having our Rhino.Inside Revit workshop with a bunch of brilliant minds, and they raised this question that if we have a design like this, which we modeled during the workshop, and we want to add those panels to a Revit schedule. So how can we add all of the data regarding those panels after adding them from Grasshopper to Revit? How can we create a schedule with the panels numbers, the panels names, giving each one a unique name and accessing their areas, their volumes, and their length and width, for example. So we started like brainstorming, and everyone gave a really good shot in this um, workflow. So I wanted to share it with you. So basically, we created this very simple building that has those panels with different um, like scales in the openings and so on. And there is just this missing something, which is the glazing. So just give me a second to add it. Yes, so I think that's it. Now we have our solid panels, those outside frame, and we have the glass panels. So here is what we want to do. First of all, we need to add those panels to Revit, and uh, as you can see from this Revit viewport, we don't have any geometry yet, right? Because we didn't add them. We didn't use any of the Rhino inside Revit components. So let's go ahead and add it using the add direct shape geometry to give those names. So basically now we need to give each one of those a unique name so we can concatenate like two fragments, one with the let's say panel, let's call it actually solid panel number. Yeah, we can just add the number near this string. So let's create a series that goes from panel number one to the total length of those solid panels. So we can just get the list length and make sure the list is flattened in order to get the right length. And right now we have those, this length will be the count. And in this case, I think we will get, yeah, solid panel 1 till to solid panel 400. Maybe we need to add this space after panel so that we have this space right here. And now we have those text, those names. We can just actually graft the names because our panels are grafted. So we need to do this. Let's just uh, reorder the code. And here our panels are grafted. So we need to graft the names coming here. We can give it like a wall, for example, a wall category, and then we can give the names, and we can even give it a material. So let's add a material here, and let's choose something like aluminium, for example. Let's choose something like wood. Yeah, we can choose any material, and then let's just connect this. And in a moment, we have our solid panels inside Revit. Yes, now we have each panel by its own, and each panel has its own name, actually. So the next thing to do will be to do the exact same thing, but with the glazing panels. So we can copy those. Yes. And let's just give them glazing panel number, and in this case it will give those names, but we have to connect this geometry, the glazing geometry. And now the resulting panel's name is glazing panel 1 to glazing panel 400. Now let's choose another material like glass or something. So basically we're going to the glass and choose clear glass, for example. Of course, the more panels you have, the more time it takes to sync with Revit. Now I guess, yeah, we have those panels imported. If you want to check the materials, go ahead and choose the realistic view, and you have your realistic material here. And now we'll go back with the shade or hidden line viewport. And what we want to do now is, if we click on any of these panels, we don't have any properties regarding its volume or its area and so on. And although each panel has a wall category, it's not even calculated when we create a schedule. So if we go ahead and create a new schedule of walls and click OK, and if we choose anything from here, like area, if we choose the count, if we choose the, for example, volume, the name, maybe, there is no name, but there is the family, for example, and so on, and we click OK, you will find that there is not a single detail about, only the count is calculated, but there is no single detail about our panel. So what can we do? What we're going to do is really great, because we will add parameters that carry the panel's names. We will add parameters that carry the area and the volume, the length and the width of each panel, and so on, and we will add these. So here's what we're going to do. We're going to the parameter tab. We're going to add a parameter, and we will have a bunch of parameters actually. So let's go ahead again and define a new parameter. And let's take all of our parameters down there. And in this case, let's give the solid panel name parameter. So a parameter that has the solid panel name. Its type should be text, and the group can be data, for example. And we will choose just an instance scope. And now let's copy this one more time and create a glazing panel name. Then let's again go ahead and create a bunch of parameters, one with a number value. So we're going down till we find the number value here. And we will give this for example, the solid. Yes, I think we're not going to give it the solid panel name. We can just call it panel area. And then we're going again to copy this and create a panel volume. And one more time, another parameter called panel length. And finally, panel width. Actually, the panel length and width can be divided. So we have like solid panel length and a solid panel width if we want. But actually, yeah, we can just call it the panel length and panel width, and then we can just using data trees manage this. So we're going ahead and calling this panel width. And if we go right now to Revit and choose any level and choose any item, now we will have under the data those parameters that we created. And now what you want to do is to fill all of this data or parameters with values that correspond to each panel, either solid or glazing. So first of all, how can we do this using Rhino inside Revit, you can go and work with this element parameter component, and it basically takes an element, gives it yeah, you can just add the parameter name that you want. So for example, solid panel name would be will be gone here. And to make it a bit smarter, yeah, let's just remove the glazing panel name, and let's just delete these, and let's just call one parameter called panel name. So we have the panel name, the panel area, volume, and so on. So this will be the parameter that holds the names values of those panels. So here's what we're going to do. We are going to just merge the two inputs. So basically we will merge direct shape 1 with direct shape 2. So the solid direct shapes with the glazing direct shapes. So we have like 400 branches. Each branch has one solid and one corresponding void panel. And we have to do this actually with the names. So we need first to add those here and here, and we need to graft the inputs so that we have the same data structure, and here we have the same exact regarding the names. So what we're going to do regarding the panel name is we just add this element here. So this is the element that we want to change the value of its parameter called panel name. So those are our elements. And then those are the values that we want for our objects. So let's check now what happened. Let's go here in the 3D view. Let's start picking our panels. So here is the solid panel number 390, and then if we click the glazing, so it's the glazing panel number 390. This should be 391, 392, 393, and so on. So now we filled the first thing. What we will go ahead and do the same exactly, but with calculating the areas, the width, the length, and the volume. So let's go ahead here, and our elements will actually remain the same, but the parameters, let's disable this so that we don't like create copies of everything. So what I'm going to do is connecting the elements remain the same, but what we want to change is their values of the parameter called panel area. So how can we get the areas? This is very simple. We can go ahead and get the area of the solid differences, and in this case let's check and make sure the areas are right, and here we go. Yes, so it gives the area of each one, but this will most probably calculate the area of not only one panel, not one face on the panel, but all of the faces. So what we want to do is connect the offset surface, not the offset surface. And yeah, we can just calculate it simply by maybe subtracting the panel area. Let's just graph the two items. So we will graph this, and in this case, we will graph the panels themselves, and then we want to subtract from them the scaled panels. So let's grab the scaled panels and connect this. Now it has the subtraction of the area of both, but we need to actually add this area component. And here we can connect the area, and then from the scaled one, we can get the area as well, and then connect it here. So now we have a result of all of the bright areas of the solid, right? And now what we want to do is to go ahead again and merge them so that we have, and don't forget to graph those two. Now what we have is the merged areas of the solid cut panels, and then the areas of the scaled panels, which are the glass panels. Now we have a list of um, now we have a list of yes of panels, but what the problem might be is yeah, it doesn't give a grafted. Yeah, now it gives just the same data structure if we ungraft those because they are already grafted. And in this case, the result is the same data structure. So 400 um, branches, each with two items. And now those will be the values that we want for the areas of each panel. Okay. And if we run this now, and enable it, now those areas will be added. So let's go ahead and check it down here. Now we have the area of each panel. So this is the area of the outer panel, and its glass should be much smaller, like zero point 0.2, and this makes sense. Right now, I will speed the video. We'll do the exact same thing to calculate the volume, the length, and the width. All right. So basically, I had a bunch of issues with the length and width, so I had to change some of the of the data order of the length and width. But now what we can see is each panel. Let me hide Grasshopper, and let's check what each panel has. So going here, for example, this will give me the panel number, the panel area, the length, and the width. Going with the frame, it will give me the solid area, length, width, and name. And going to the smallest ones even, so we have a panel area of 9.9, but with the small one, it takes a zero point 0.2 area panel, glazing panel. Now, what we want to do is we want to get those information in a table, so we're gonna check our wall schedule here that we created before. We need to edit the fields actually and remove everything that we have here. Maybe we can just leave the count and that's all. And let's add some new things. So basically, I want to add the panel name, and that would be the first attribute of the field of the or field. And then we can add its area, and then we can add the length and the width. And in this case, if we click OK, now we have the panels names here, their areas, their length and width. And going down there, we are going to find the glazing panels, each named from 1 to 400 or 399, and then each one additionally with its information. I want to thank everyone who participated in this session of the workshop. Namely, I would like to thank Abdulrahman Debsi. I would like to thank Malak Tawfik. I would like to thank Awadi, Hazem, and Pola, who were all a big part of just exploring this workflow. Thank you for watching and see you in another video.